getting it together. One moment, I'm sorry. Welcome back. We're live. We're live today. We are here. And in doing so, we're going over fractions. I believe this is the last section. And it is dividing fractions, which is pretty nice. Not so far and away from multiplying fractions, I mind you. Oh man, there are more sections. There's one more section after this, I'm sorry. So, let me finish getting setting up just a wee bit. There we go. Let's see. One moment. I didn't get the right thumbnail together. Yep. Excuse me. I rushed things, so no, not everything is correct. Here we go. All right. Here we are. All right. Thank you for being so patient. Man, there's a lot of clicks, a lot of work. But that's fine. Part of making a math video is not only being competent at math, but knowing how to video. So, all right, today we are working on dividing fractions. Good grief. All right, so before we get into things, we have a couple of words that are very important for the division of fractions. We have thank you. Me and this camera are going to wrestle for a little bit longer. It's a good camera. Yeah. Okay. So, first word here is reciprocal. It's I of a fraction. So what this is if we're given the example of 3/4, the reciprocal of this fraction is 4/3. The reciprocal is swapping the numerator and the denominator. That is, we invert or turn over a fraction to write it as the reciprocal. So it is still a fraction, it's just rewritten. Right. The word for reciprocal, very important. Different examples of reciprocal. If we can do this with 3/4, we can do this with pretty much every fraction. So the reciprocal of the whole number 5, well, 5 has that understood 1, so the reciprocal is 1/5. We have 1 and 2/3. We must first move this to a mixed fraction, or improper fraction, as it's a mixed number. So 1 and 3 is 3, 4, 5. So that equals 5/3. Reciprocal is 3/5. Another example, we have 5/8. The reciprocal is 8/5. 3 1/4. First 3 times 4 is 12, plus 1 is 13 fourths. Reciprocal is 4/13. Very straightforward approach, very easy kind of math to do. Technically, what you are doing when you're finding the reciprocal is 1 divided by that fraction. So A, or alpha over beta, or A over B. So this is what you are doing when you find the reciprocal. Because when you divide by a fraction, you are multiplying by the reciprocal. So the core concept to multiplication or division of set that over here. Oh my goodness. Me and technology are going to go round and round today. Is when you that is essentially what you're doing. Is that I'm going to throw you. Oh heavens. Oh my gosh. Okay, there we go. Yes. Sorry, me and this camera, we're about had it. Yes, when you divide by a fraction, you multiply by its reciprocal. So we have an example of 2/3 divided by 4/5. So we are dividing by this fraction. So we must rewrite it such that you are multiplying by the reciprocal of 4/5. So that would be 5/4. And now we know, because we know how to multiply, just to cross. And the 2 and the 4 can reduce real fast. So you get the 1 and the 2. So 1 and 5 is 5. 3 and 2 is 6. Using the same fractions here, humorously enough, this is also written as 2/3 divided by 4/5, which is a lot of over-under stuff. But I find what's really nice, first, putting parentheses over what your actual fractions are helps immensely to discern where what line is important. And then at this point, what's something I have kept in mind, something that I hope is useful to you, if you have a fraction divided by a fraction, this fraction pushes down on this fraction, so the bottom part multiplies by the topmost part, and the 3 and the 4 multiply. It's a very convoluted way to see it, but it's a very physical, hands-on approach. Does that make sense? I'd hope. So then you'd get the 2 and the 5, which would be a 10, 3 and the 4, which would be a 12, because you have pushed. There's an intermediate step because you have pushed it. So now you have this 2 times 5 in the top, and then you get this 3 times 3 times 4 in the bottom, because this becomes a multiplication problem. Something for. So that multiplies to be 10 over 12, which reduces to 5 over 6. Now, I wouldn't expect too many people to use the push method because it makes it more complicated to get to your final answer. It is easier to find the reciprocal and then multiply? Because that is essentially what you are doing here. You're just making it more of a physical problem. So if we're given another example, yeah, sorry, 3/5 divided by 7/8. I think that's gonna just be on it. Nope. There we go. Seems like light was the culprit. So then we have 3/5 divided by 7/8. So divide by 7/8, we find the reciprocal, so that is 3/5 times 8/7. None of these pieces reduce, so we multiply across. 3 times 8 is 24. 5 times 7 is 35. And as something didn't reduce before, this will not reduce further. So I'll show the push method. The 3/5 divided by 7/8. This pushes down. The 8 is multiplied by 3. And then 5 and 7 are multiplied. So 3 and 8 is 24. 5 times 7 is 35. That doesn't reduce. So that is what we get. So I've seen another approach to this. And we're just going to go through several approaches. Whatever sticks with you, you should use. Because, again, math should be done more ergonomically in a way that you can do it. Despite there being like a right or wrong way to do it, there's a lot of more right ways to do a problem than we are initially given. You can use various methods to check your work, but if there is a method that speaks to you and that works for you, please use that. Get good. Get good at that. So this other tactic, we're going to use that 2/5 divided by 3/4. So 2/5 divided by 3/4. We are going to find the reciprocal because we have this as 2/5 divided by 3/4. We find the reciprocal, which would be 4/3. Now, this is a bit convoluted. But you find this reciprocal and you multiply it by both on the top and the bottom. Because a reciprocal of a fraction times that fraction, 3/4 is 12. 3 times 4 is 12. 4 times 3 is 12. 12 divided by 12 is 1. So that is just 1. A fraction times its reciprocal is 1. Very simple. Very straightforward. That's why it was made. So therefore, the bottom becomes 1. So the top, multiply across, 2 times 4 is 8. 5 times 3 is 15. And then 8 times 15 all over 1. Anything divided by 1 is itself. If you use the push method, that's 1 times 15, which would just be 15. So that is what we have. Right. So we could use another example. I'll just a push method, not just the, I'm going to say it's convoluted, finding making the denominator 1 method. So now we have 3 methods that we can use. So we'll have another example that we'll do all 3 ways. So 4/9 divided by 8/15. So attempt A is the reciprocal method. 4/9 times the reciprocal, 15/8. Go ahead and find what reduces. So 4 and 8 can fit a 1, or a 4 once and a 4 twice. 9 and 15 can both fit a 3 times and 5 times. So then 1 times 5 is 5, 3 times 2 is 6. Approach B, making the denominator 1 method. So we have 4/9 over 8/15 times 15/8. 8 times 15 is 80 plus 40 is 120. 15 times 8 is 60 plus 60, which is 120. And then 4 times 5 is 60. And 9 times 8 is 72. 120 divided by 120 is 1. So we've made the denominator 1. And 60 and 72 can reduce, as both are divisible by 12. So 5 and 6. And that can be rewritten as 5/6. And then the last method, the push method, 4/9 divided by 8/15 lead into 4 times 15 over 9 times 8, which you may see at this point is just coming back to the same notion that 4 times 15 over 9 times 8, 4 times 15 over 9 times 8, all over 1, which is 4 times 15 over 9 times 8. The approach is more or less how you set it up. The result should always be the same when done correctly. So 4 and 15 is 60, 9 and 8 is 12, 72, and I said 6D. Oh boy, it's been a long day. So 60 and 72 are both divisible by 12, which would make for 5 and 6. So then you get 5/6 again. So why do we divide fractions? So let us think, if we have a box, just some arbitrary square, and we're trying to fit, let's say, 4/5 of some piece of box in here. Well, first we want to know the area, whatever that is provided. Let us say the area is 3 7/8, some unit feet squared. That is some area. And you're trying to see how many of these pieces you can fit into it. Now, normally, without a fraction, using whole numbers, if this area was an even 36 feet squared, and we had these things, which had some 6 feet squared a piece, we would have 36 divided by 6, and you can put 6 squares in the big square. So that is why we deal with fractions, because sometimes our boxes and squares are not a nice even round number. Sometimes we have to know what fractions can fit into what. So in this example, we have 3 7/8 divided by 4/5, and this is in feet squared. So 3 times 8 is 24. 24 plus 7 is 31/8 divided by 4/5, so multiplied by 5/4. Nothing here can reduce. 5 times 31 is 150. 155. This is an extra 1. 8 times 4 is 32. And then 32, since this is an improper fraction, we can reduce. How many times can 32 fit into 155? Well, 32 is close to 30, a little bit bigger. So not quite 5 times, so maybe 4 times. So 4 and 3 is 12. 4 times 2 is 8. 155 minus 128 is 27 remaining. So this is 4 and 27 30 seconds. Feet. Or, excuse me, not feet, mind you, because in the previous video we figured out that we need to divide our units as well. So this is squares. So because a refresher on units, we have this many feet squared divided by the 4/5 feet squared. And the feet are the same because they are both squared feet. They cancel out, leaving this to be that 4 and 27 30 seconds. And what does it describe is how many squares can fit into the big square. So that's as many squares as you can fit. So, I'm giving a further example. And because we know several things about fractions, how to change them from mixed numbers to improper fractions and back, we know how to multiply. Every other problem going forward is just going to have built on that, such as dividing two mixed numbers. So if you have 2 and 3/8 divided by 1 and 3/4, first you must rewrite them as improper fractions. 2 times 8 is 16, 17, 18, 19 over 8. I'm going to multiply by the reciprocal of, first off, 1 times 4 is 4, 5, 6, 7, so that is 7/4. The reciprocal then is 4/7. Before we multiply, we see that 8 and 4 can reduce. 4 can fit into 8 twice, 4 can fit into 4 once, and now we can multiply. 19 times 1 is 19, and 2 times 7 is 14. 14 is smaller than 19, so this can be rewritten as the mixed number. 14 can fit into 19 once, with a remainder of 5 14s. Yep. I need more paper. So then we get different pieces. In the example of 8 divided by 4/5. No, excuse me. 4 and 4/5. And so we will rewrite 8 as a fraction just for our own ease. Multiplied by, first we have to rewrite, 4 times 5 is 20. 20 plus 4 is 24 over 5. So we have, I'm sorry, we've rewritten it. Now we find the reciprocal. which is 5/24. 8 and 24 have an 8 in common, which reduces 8 to 1, 24 to 3. We multiply across to be 5/3, and rewritten as 1 and 2/3. Oh. Back to a word problem that is very important, because math otherwise is just dealing with a lot of adjectives if it's not describing something. And the word problem here is we have 500 miles to go somewhere divided by the gas mileage on our vehicle gets 25 miles to 1 gallon. Yep, that is correct. So we're trying to see how many gallons we need to have in order to make it the 500 miles. So that 500 over 1 times the reciprocal, which is 1 gallon, over 25 miles. Keep your units. We have a miles in the numerator and in the denominator, so they cancel. And then there's nothing to cancel out the gallons. And the only thing that can reduce is the 525. Now 25 can fit into 100 4 times, and there are 5 100s, so 5 times 4 is 20. Yep. Okay, I believe that. It took me a second. I was like, didn't know if that mathed right. Because 500 divided... Fine, I don't believe myself. So 25 can fit into 50 twice. And then 25 can fit into 0 times. Yep. So that would be 20. And that is a 1. So 20 times 1 is 20. 1 times 1 is 1. So that is just 20 gallons to make it 500 miles on a vehicle that can do 25 miles per gallon. So we have another example here of Jacqueline traveled 140 kilometers in 2 1/3 hours. What was their average speed? So a speed is usually done in kilometers per hour. So simply enough, that is 140 kilometers per 2 1/3 hours. But I'm pretty sure they want us to reduce, so we must do the division. So that is 140 over 1 divided by 2 1/3, rewritten as a mixed or a improper fraction. 2 times 3 is 6, plus 1 is 7 thirds. We have kilometers here, and we have hours here. And so, to divide, we must have a reciprocal times 3/7 kilometers hours. So then we have kilometers over hours. No labels cancel out. So our answer is going to be kilometers per hour once everything reduces. Let's see. I'm trying to think. 3/7 hours is plural because it is not just 1 hour. 1 hour is singular, so we have it as 1. And so that's why we have hours, but it is the same unit, even though we've dropped the S. It's the difference between plural and singular, and that is just fine. They are still the same unit. Then we reduce 140 and 7 both have a 7 in common. So 7 fits into 7 once, 7 fits into 140 20 times. So 20 times 3 is 60. 1 times 1 is 1. And just because we know things about things, it takes approximately 1.609 kilometers to equal a mile. It takes more than 1 kilometer to equal 1 mile. So this is slower than 60 miles per hour. Just to compare, so if you may need to know, if you ever look at your odometer and you have you've gone 60 miles per hour, but it also shows your kilometers on the inside. So that's why. And your kilometers will probably be greater, something in the ballpark of 80, 85 kilometers when you're doing 60. And if you're doing 60 in kilometers, you're probably doing something closer to 50 or 40 miles per hour. Just thought that was a clever little thing to know. Okay. So another example would be an electrician needs pieces of wire 2 3/5 inches long. So 2 3/5 inches. She has a 20 4/5 inch piece of wire. How many of the shorter pieces can she get out of it? So this again is 20 4/5 divided by 2 3/5. So then we change to an improper fraction, and then we proceed with the division. So 20 times 5 is 100, plus 4 is 104 over 5, divided by 2 times 5 is 10, plus 3 is 13, denominator of 5. And we switch from division to multiplication by reciprocal. So 104 and 5 times 5/13. The 5s will cancel out, leaving 1s in their respective places. I don't see anything simplifying here so much, not just offhand. So we can multiply across 104 divided by 13. This is an improper fraction, so we're going to try to turn it into a mixed number. 104 divided by 13. 10 times 13 is 130. So I'm going to guess 8, because that seems about right to me. So 8 times 13 is 80 plus 24. Well, holy cow, that's exactly right. I guess it did reduce. So there is no remainder. So this simply equals 8. So she can get 8 pieces of 2 3/5 inch pieces of wire. It's kind of lovely. You can kind of guess, and even if I guessed wrong, if it was 7, there would be a remainder of 13. If there was a 9, the number would have been too big. So just trying to guess what feels right and see what remainders there are, see if you need to go back and adjust. Let's say if I needed to adjust. So that was 104 divided by 13. If I guessed 7, so 7 times 13 is 70, plus 21 is 91. So that is 104 minus 91 is 13. So that's a whole 13. This is the same. I would know I would needed 1 more. And if it was 9, then this would have been too big. That would have been 117, which is too big to fit into 104, so could not have been 9, as 9 would not have fit. I'm going to do one more example. And then we're going to work some of the next section work. Go ahead and wrap up this chapter on multiplying and dividing fractions. So this last example has Jackson has 6½ yards of mulch. His garden needs 2/3 yards of mulch per row. How many rows can be covered with what he has? So this is 6½ divided by 2/3 yards. So 6½ rewritten as an improper fraction. 6 and 2 is 12, plus 1 is 13. This is already a fraction, so we can go ahead and multiply by the reciprocal of 2/3, which would be 3/2. So this is yards divided by yards, or multiplied by yards on the denominator, so they cancel out. And so 13 times 3 is 39. 2 times 2 is 4. This is improper, so we will rewrite it as a mixed number. 3 can fit into 39 9 times, so that would be 39 minus 36, which would be 3/4 rows. So what this shows is that you can make 9 neat rows, and then one of your rows is going to be short. I think that'll cover pretty much dividing by a fraction. We're going to go ahead and jump into what is the last section. It's an optional section, so of course we're going to do it, of computer-related applications, particularly with time. Time is a finicky thing, whether you have it or not. So we have an example. To convert 1½ years into minutes. Something that computers can do really well, really quickly, because they have the formula for this. And so they'll take this 1½ years and then they will multiply it by how many days are in a year. There are 365 days per 1 year. Multiply it again by 24 hours in a day. And multiply it again, since we're getting to minutes, 60 minutes per 1 hour. So this is what we were given, and these are the ratios that we will work with to move this into minutes. So before we do any multiplying, we're going to turn this years into an improper fraction so we can work with it. 1 times 2 is 2, plus 1 is 3, so 3½ years times 365 days per 1 year times 24 hours per 1 day times 60 minutes per 1 hour. And this is our goal from here. Now, before we do anything with the numbers, go ahead and cancel out your labels. And just because things are plural does not mean they're any different than they're singular. So we have years days, and hours. Making sure all the labels cancel out that need to cancel out, and all that's left is minutes. So then we have 3 halves times 365 times 24 times 60 minutes. And we will go through, but I'm going to get my calculator out so I remind myself to check myself. Because one wrong calculation and the whole problem can be wrong. So we shall, for that 2 can fit into 24 or 60. I'm going to fit it into 24. So 2 can fit into 2 once, 2 can fit into 24 12 times. So 365 times 3 is, from right to left, 319, 1,095 times 12. So that is 10950. So that is 990. So 5 and 9. And 13,140. 13,140 times 60. So we know the first one is all zeros. We'll just add a 0 and multiply by 6. 6 and 0. 6 and 4 is 24. 6 and 1 is 6, 7, 8. 6 and 3 is 18. 3 and 1. 6 and 1. 6 plus 1 is 7. So 1.5 years should be 788,400 minutes. Now, before moving on, let us check. We have 1.5 years times 1.5 times 365 days per year times 24 hours per day times 60 minutes per hour. So yep, that achieves us that 788,400. Isn't that nice? So I believe we're only going to do a few of these as they will become more convoluted. They expect you to use a computer to do this. However, we are going to do this by hand because by hand is subjectively superior. Let's see. Trying to see what we were given, what we can do. Yep, trying to pick and choose an example. So we have the definition of a millisecond. So a millisecond, I have to establish this definition before we can do this further example, is 1,000 milliseconds per 1 second. And then a microsecond is 1 million microseconds, which is, that's not lambda. What is that? Mu. I believe this is pronounced mu. It's a Greek letter for microsecond per 1 second. So that also means 1,000 microseconds per 1 millisecond. So, with this in mind, how many milliseconds are in 1 hour? So, a millisecond is 1,000 milliseconds per 1 second times 60 seconds per 1 minute, and there are 60 minutes per 1 hour, and we're trying to get to that hour. Times the 1 hour we were given. So we must cancel out the labels first. The seconds, the minutes, and the hour leaves us with milliseconds. So 1,000 times 60 is 60,000 times 60 again. So 6 times 6 is 36. Put another 0 in there. So that is 3,600,000 milliseconds in an hour. And just because we need to check, 1,000 milliseconds times 60 is 3,600 and 3 more. So, yep. And then another example is how many microseconds are in 20 minutes. So we have 20 minutes times, we have 60 seconds per 1 minute. And then we have, microseconds per 1 second. The minutes cancel out, the seconds cancel out, and so we're left with 20 times 6 times 1 million. 2 times 6 is 12. There's 1, 2, 3, 4, 5, 6, 7, 8 zeros. And so we have, hundreds, thousands, millions, 1,200,000,000 microseconds per 20 minutes. So 20 minutes times that 60 seconds per minute times that 1 million microseconds. We have 1, 2, 3, 4, 5, 6. That's 1,200. Yep. So that's our 1,200 million, 1,200,000,000 microseconds. So yep, numbers are insane, especially when you start getting very, very small numbers. So we talk about microseconds and milliseconds. There's also a nanosecond, which, as you can tell, we have 1,000, 1 million. A nanosecond is 1 billion. Denoted as a nanosecond per 1 second. And these numbers start to become important, especially when you're dealing with electricity. For the fact that we are streaming right now means all the data that is being taken into my computer here on my end is being processed so very quick so that it can almost be brought to you at at the exact time I say so. So right now, putting pencil down, so it may take a couple seconds to reach you, but a lot is being done in each one of those seconds. So a lot of processes are being done in nanoseconds, microseconds, milliseconds. So, knowing that, right, let's see. Knowing that distance, distance is the speed or rate of something times time. We know that electricity moves travels just about at the speed of light, which is also 186,000 miles per second. It's a little quick. So miles per second. That means that in 1 second, light travels nearly 3/4 the distance from Earth to the moon. It's pretty quick. That means when you're seeing the moon, you are seeing it a little over a second ago. So the fact that we can communicate over the internet just as fast as we can see the moon is a very impressive thing at this point. Which also depicts the fact that we can find the distance to the sun based off the same thing, because the light that we get from the sun takes about 8 minutes to get here. I think that's right. So if the sun were to just blink or to go out, we wouldn't know for about 8 minutes. And that's a pretty long ways away. So, the question is, how far can electricity travel in 1 millisecond? So in 1 millisecond times 186,000 miles per second, times 1 second per 1,000 milliseconds. So we're trying to find the how far, so we want to isolate the miles. So we have 1 millisecond, which can be rewritten as 1 over 1, so 1 millisecond, times 186,000 miles per second, and each second is 1,000 milliseconds. So we go through and cancel out the labels, the descriptors, milliseconds, and the seconds, so we are left with that miles. We have 186,000 divided by 1,000. They have these 3 zeros in common. That means they have that 1,000 in common. So that reduces the 1,000 to 1, reduces 186 to 186 miles per millisecond. That is still very quick concept. So another part to this question, since we're looking at milliseconds, let us look at microseconds. So in 1 microsecond, microsecond, we're looking at 186,000 miles per second times 1 second per 1 million microseconds. So same setup, different value that we're looking for. So the microseconds cancel out, the seconds cancel out, we are left with that miles. And we have the 3 zeros again, so that leaves us with 1,000 and 186. So that means 186 over 1,000 miles. Now you can, and I'm probably going to do this more with a calculator than with division, just because I'm curious and it's of no real consequence to reduce this otherwise. 186 divided by 1,000. Well, of course it's 0.186. I forgot. I didn't know what I was doing. When you divide by a multiple of 10, that'll reduce decimally to the numerator in the tens, hundreds, thousands place. And so that we know, there's 5,280 feet per mile. So that means you can get that 186 over 1,000 miles times 5,280 feet per 1 mile. And this is going the extra step. This is not part of the question, but 0.186 miles is not as easy to picture as putting it into feet. So we have 186 divided by 1,000. So this boat has a 10 there, divisible by 2. So that's 50. So 2 can fit into 528. 264 times. This can divide by 2 again. 132. And again. Well, no, this doesn't divide by 2 anymore. So this is 132. So you get 186 times 132. Divided by 25. So this is 186 excuse me, I wrote this one out. Yep. Yep. 1, 2. 8 and 6 is 14 plus 1 is 15. Carry to 1. 1 and 6 is 7. Mercy, I just put it way over there. So 1 plus 6 is 7, plus 4 is 11, 12, 13, 14, 15. 1 plus 8 is 9, 12, 14. And then 1 plus 1 is 2. So I'm going to check my math on that since I wrote it really, really weird. So that was fine. So then you get 2, 4, 5, 5, 2 all over 25. So 2, 4, 5, 5, 2 divided by 25. 25 can't fit into 24. 25 can fit into 249 times. So we know 8 times is 200, so that'd be 225. So that is 20 and 5. 25 can fit into 205. Oh, I'm sorry, for 8 times. So 8 times 25 is 200. Leaves that 5. Bring that to 2, can fit into there 12. So 2 25ths. So about 982 and 2 25ths feet in 1 nanosecond. And this is pretty small in comparison to this number. So we can round or estimate for any practical purposes to just 982 feet. Thank you for hanging out with me on that. I really was compelled to finish that out and write it as feet. Alrighty, we have come to the end of time. The end of time for today. So we have finished up the chapter on fractions, multiplying and dividing fractions. Any questions, comments, concerns? Let me know. Let's see. And I will try to check comments as they come up from previous videos as best I can, because lovingly YouTube lets me know. And if there is a more convoluted question or something you have to draw or write out, let's see. My email will be here in the chat. Yeah, that should be me. So if you need to take a picture, let's say, of your homework and need something explained, please send it to me via email and I'll get back to you, probably in a YouTube short of some kind or a YouTube video depicting the answer to that question. That is the hope going forward. Today is Thursday. The next video I hope to go over will be next Tuesday. Let's see, what day is that? The 8th, Tuesday the 8th. And we'll go over a quick summary of everything in multiplying and dividing of fractions up to this point, some summary exercises to show these fractions being multiplied and divided before going into the next section, which is adding and subtracting fractions. But you would think that would come first, but it is easier to understand the multiplication and division than adding and subtracting fractions. So that is what I have for you today. I'm going to log off and go have some dinner and relax. This has been a very in-depth look at the division of fractions. I appreciate you being here, and I will see you in the next video. Bye.